Hello, this is Lisa. In this video, I'll be talking about exponential expressions and the product rule. First, a few definitions. Number one, an exponential expression must have a variable raised to an exponent. An example would be x to the fifth power. X is our variable and 5 is the exponent. Exponential notation involves writing a base raised to a power or exponent, such as b to the x. So some other examples of expressions written with exponential notation would be y to the second, or sometimes when we have the second power, we call it y squared. Or we could have z to the third power, and when we refer to things raised to the third power, we say they are cubed. And then all of the other exponents we just designate by their numeric name, x to the fifth, x to the sixth, etc. In the following exponential expressions, we're going to identify the base and the exponent for each of those expressions. So we have three separate expressions here, and we're going to identify base first. So 6y squared, the base, what is being raised to the exponent? That is just the y. This expression is 6 times y squared. Negative 1/2 x cubed. Remember again, there's a multiplication here. Negative 1/2 times x cubed. The thing that's being cubed is just the variable x. And 2.5 y to the fourth, our base is the variable y. The exponent in each of these expressions, 6y squared, the exponent is 2. Negative 1/2 x cubed, the exponent is 3. And 2.5 y to the fourth, the exponent is 4. Write each expression in exponential notation. Well, the base tells us what number is being multiplied. Here we have 3 times 3 times 3, so 3 is our base. And the exponent tells us how many factors of 3 do we have. In this example, we have 5 factors of 3, so this is 3 to the fifth power. In example 2, if we look at what's being multiplied, negative 5x times negative 5x times negative 5x, in parentheses, negative 5x, all of that is what our base is. We need to use the parentheses to identify that as our base. And then how many times do we have that? 1, 2, 3, 4. So our exponent is 4. The opposite of writing an exponential expression is to expand or to evaluate the expression, which is what we're going to do next. We're going to be evaluating the following expressions. Negative 2 to the fourth power. In parentheses, everything inside the parentheses gets raised to the fourth power, or it means we have to write everything in the parentheses 4 times. This is negative 2 times negative 2 times negative 2 times negative 2. We can multiply going straight across. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And when we multiply negative 8 times negative 2, we get a positive 16. That will be our answer. Now, you can also do exponential expressions that are numeric. You can do those on the calculator. So I've gotten out my calculator, and there are two ways that you can do these on the calculator. You can type it in negative 2 times negative 2 times negative 2, or we can type it similar to the way that it's written. Parentheses, negative 2, close parentheses, and then to get an exponent, there's a square key on the face of the calculator, but I say you can do any exponent if you use this caret key, this little up arrow key. So we're going to do negative 2 raised to the 4th power. And that will tell us that it's 16. Now, you want to be very careful when you're doing these exponents on the calculator, because in the next example, we say we have negative 2 to the 4th power. There are no parentheses here. So the only thing that is being raised to the 4th power is the base 2. We have one negative sign, and then we have 2 times 2 times 2 times 2. The 4 only works on our base, which is 2. And so this particular answer, one negative sign, our answer is going to be negative 16. So on the calculator, if I bring my calculator back up, we saw negative 2 in parentheses raised to the 4th power is 16. So if we type negative 2 raised to the 4th power on our calculator, and we type it correctly, it will give us negative 16, because the calculator understands that without the parentheses, the base for our exponential expression is only the number 2. Let's look at a couple more examples. Evaluate the expression 5x cubed when x equals 2. Again, here we have to remember we have 5 times x cubed. So 5 times 2 to the 3rd power. And some people always like to substitute putting numbers in parentheses. It does not hurt to have the parentheses there. You can do this on your calculator, or you can use order of operations. We do the exponent before we multiply, so we'd have 5 times 2 to the 3rd. 2 times 2 is 4, times 2 is 8. Because remember, 2 to the 3rd means we have 3 factors of 2. So that would be 5 to the 8, 5 times 8, or 40. So again, we can do that on the calculator. 5 times 2 raised to the 3rd power, and it will give us 40, all as one calculation. 5 times x cubed when x equals negative 2. Here's that place where this time we really do need the parentheses there so that we know our base is negative 2. The number that we're plugging in for x, which is all being raised to the 3rd power, is negative 2. And so this is going to give me 5 times negative 8, or negative 40. And again, if we look at that on the calculator, 5 times, here we do need parentheses, negative 2 raised to the 3rd power, and it gives us a negative 40. So those expressions can be done on the calculator using that caret key. The product rule says for any real numbers x and y and b not equal to 0, b raised to the x power times b raised to the y power equals b to the x plus y. So multiplication and addition sort of go together here. The important thing is that you have to have the same base on your exponential expressions. So let's look at some examples. Example 1 says we have x squared times x cubed. Now, if you think about what the powers of x mean, x squared means x times x, and I'm multiplying it times x cubed, which means I have 3 factors of x. And if I look all together, then I have 5 factors of x, or x to the 5th power. When I was a student, I didn't like to remember rules like b to the x times b to the y equals b to the x plus y. I used to pick a simple example like x squared times x cubed and just remember how to do that. And when I use the rule, it says x squared times x cubed is x to the 2 plus 3 or x to the 5th. Either way, I get x to the 5th. But when you start getting larger and larger numbers for your exponent, it's harder to expand it out and write it. It's much easier to be able to apply the rules. In example 2, we have 2 to the third times 2 to the fifth times 2. Remember, just plain 2, that's one factor of 2. Our exponent there would be 1. We keep the same base, all of them have base 2, and we add the exponents, 3 plus 5 plus 1, which gives us 2 to the ninth. Example 3 says we have x squared y times x cubed y to the fourth. Remember, our commutative property allows us to change the order. So I want to put my x's together. I have x squared times x cubed. I have y, and remember, y means y raised to the first power. I have just one of those y's times y to the fourth. X squared times x cubed. We already saw earlier, if I add my exponents, 2 plus 3 makes it x to the 5. Y to the 1 times y to the 4, 1 plus 4. This gives me y to the fifth. And I have simplified my exponential expressions by combining the expressions that had like bases. Just like we did like terms earlier, we want to make sure that we're only adding exponents on bases that are the same. And that concludes this video. You should be working on the homework for section 7.1, followed by the quiz. Have a great day.